Bismillahirrahmanirrahim. Okay, beta, today we are starting movement. Movement is also known as torque, and both mean as turning. Movement and torque both are same terms, and both means turning. When something is turning, and scientifically, the movement is turning effect of a force. And where it is involved, so beta, if the wheels of a vehicle will turn, only then it will move, right? Even for an aeroplane or a rocket, it needs a thrust from the air, and air is produced by the turning of very high powerful engine or fans. When you have to open a cap or nut, loose or tight a nut, you have to rotate it, turn it, right? Even over joints, turn when a bowler bowls, he turns his hand. Even the movements of the joints, they are of turning type, means in every movement, in one over way or the other, turning may be involved. So coming back to movement is called the turning effect of a force. And to turn something, first of all, we need a force. So obviously, larger the force we apply, the faster or greater will be the turning effect, right? But it is not only the force which is required, which matters. There are lots of other factors. For example, consider this is a nut, and this instrument is called a spanner. Many other instruments can be used in place of it. So with this, we can turn the nut and we can loose or tighten the nut, right? First of all, there is a term involved. Whenever there is a turning, there is a center of rotation of the turning. That is called the pivot. That is a very important point. Whenever something turns, it has a center of rotation. That center or axis means line of which is at the center of rotation is called the pivot. Uh, the most important identification of pivot is that the pivot remains at its position during even during rotation. Like you see this spanner, if we apply the force here, the spanner will rotate, but the nut remains at its place. Will it be moving anywhere? It will rotate, but it doesn't leave its position. So, beta, the pivot remains at its position. Now, what we see, if this is a nut and the center of the nut is the pivot, if you apply using this spanner and you apply the force in this direction, without being scientific, tell me, will the nut be rotating? Yes or no?
No.
No. Why? Because the force, direction of force is passing through the pivot. But when we apply the force here, now what do you think? Should it turn or not?
Yes, it should.
It will turn a bit.
It should. But what if we apply the same force here? What would
It
be
will
the
turn.
effect?
It will be more easy to turn it.
Very easy, more easier. It will turn faster rather, right? It
Yes.
means the turning effect is increasing when we are getting away from the pivot. It means larger the distance from the pivot. And what is that distance? That is not simple distance. It is the perpendicular distance between pivot and not the force. The direction of force. This is really important. Like if we apply the force in this direction without being scientific, do you think that the nut should turn? Yes or no? Why? There is lots of gap between the pivot, and we said that greater the distance, larger the turning effect. Actual, the direction of force is passing through the pivot. The distance what we are talking about is the perpendicular distance, and that is distance between the direction of force and the pivot and making 90-degree, both the distance and force making 90-degree with each other. 90-degree means perpendicular, right? Clear? The force
Yes,
should
sir.
make 90-degree with the distance from pivot and force should make 90-degree with each other. So this is not the distance between the force. Here the distance, there is a distance between force and pivot. But actual the distance is between the pivot and direction of force, line of force, right? So here the line is going in this direction and it has a perpendicular distance. But what about this? This green force was passing through the origin, the pivot. So there was no perpendicular distance. Perpendicular distance can be said to be the gap. There is no gap between there is no gap between the direction of force and pivot here. There is no gap between the pivot and direction of forces passing through the pivot. There is no gap. So that is why there was no movement or rotation. Right, beta? Clear? Right, Surosh?
Yes, sir.
So perpendicular distance is not just perpendicular distance between pivot and force. It is the perpendicular distance between pivot and direction of force means it is the distance from the pivot to the force which makes 90-degree with the force. Clear? So beta, the force, the moment not only depends upon force but depends upon perpendicular distance. For another example, we have thousands of example around it, and one we have done thousands of time in our life. Like we have a gate and these hinges are the pivot. So what do you think if we apply the force here, will it turn easily or at position B? What do you think?
Position B.
So why it turns more faster? Will have larger turning effect. It will have a larger distance from the
A.
pivot.
Delta.
Right, Surosh and Hassan? The
Yes,
A,
sir.
the force at A will have a smaller distance and B will have a larger distance. And similarly, when we hit a ball with cricket bat, you can take any stick instead of it, spite of but other than this. If let's say we are gripping the stick or the bat from here, this point can act like a pivot. So here is the pivot, and if the ball hits here, we clearly see its impact or the shot force on the ball will be lesser, but here it will be very strongly hit. Why? Because for this, it will have a perpendicular distance from pivot larger, and this one is having a smaller. So, beta, what we have discussed so far, moment is turning effect of force. Yes, it depends upon force, but other than force, it also depends on perpendicular distance between pivot and direction of force, line of force, right? Clear? Moment is
Yes,
a
sir.
vector quantity and its formula is force multiplied by perpendicular distance.
Perpendicular distance.
Now, here we are applying force in this direction and it will rotate the spanner like that. If we apply the force here, it will rotate, make a circular. So this perpendicular distance now acts like the radius of the circle. What I mean to say is this, when we apply a force like that and it makes the spanner rotate, a circle is made by the force, right? It follows a
Yes, sir.
circular path. Then that distance is acting like the radius. So beta, we can represent that perpendicular distance to be the radius. So we can write the formula force multiplied by perpendicular distance F into R. And let me tell you, R is the perpendicular distance between the pivot and direction of force. Right? Clear? So from now on, our formula is going to be F times R. Is it clear, beta ji?
Yes,
Yes,
sir.
sir.
Okay. Now, let's see. Before we move on, there are two things which I want you to know, want you to note, and those are going to be very, very helpful for you when doing trigonometry. And what is that? Because these are three right angle triangles, right? And let's say the distance in front of perpendicular is hypotenuse is d. The length in front of hypotenuse, the 90-degree is hypotenuse is d. The length in front of 90-degree angle is hypotenuse is d, right?
Yes, sir.
And for other two sides, let's say if there is an angle theta, the length which is adjacent to theta is d times cos theta, and length which is opposite in front of theta is d times sin theta. Similarly, the length adjacent which is in contact with the theta is d times cos theta, and length in front of the theta is d sin theta. You have to note these three diagrams. These will be very helpful for you, not only in this chapter, in coming chapter as well. Let's say here it is angle theta and length which is adjacent to angle is d times cos theta and the other is length which is in front of sin theta is d sin theta. Right?
Yes, sir.
Clear? Okay. Acha beta ji. So I want you to note it down. Beta, what we have discussed is beta, consider here we are having the spanners, the same spanner here again. Beta, sometime na, we apply the force like that to rotate it anti-clockwise when we are losing the nut. We apply the force like that, like the green one, at 90-degree, and the distance is r. Simply here, the moment will be f multiplied by r. This is f, and r is the perpendicular distance between pivot and line of force, right? Clear? But if we apply the same amount of force in this direction 2 at an angle or direction 3, we experience one thing. Now the moment or turning effect is lesser than as it was at position 1, the green. Why? Any idea? Why the moment is lesser here?
Sir, the angle has decreased.
Very right. You are right. Very right. Lekin, I want you to tell according to the formula. What is the formula for moment? Moment is the
F
force
into perpendicular
multiplied
distance.
by perpendicular distance. So here in position one, the perpendicular distance was r. But when it is acting in this direction, the distance we take from pivot. What is the perpendicular distance from pivot between pivot? Means the distance is to be taken from the pivot to the direction of force, making 90 degree to the direction of force. So in that scenario now, the perpendicular distance will be this. And can you notice down? This will be lesser than r. So here perpendicular distance will be lesser as compared to r. So it means the turning effect will decrease, right?
Yes, sir.
Similarly, if the force is applied in this direction, we have to take this distance, which make 90 degree with the direction force, and you can clearly see this perpendicular distance will be lesser than this. So lesser the perpendicular distance, lesser will be the turning effect, right? Okay. Now, when I'm repeating here, at position or direction one, the perpendicular distance, the force was acting perpendicular to the distance. So moment was F times R. But when the forces are acting at some angle, then perpendicular distance is lesser than before. That makes the turning effect lesser. So what will be the formula? Now the turning, this perpendicular distance will be in front of the angle. Let's say this is a right angle triangle you consider here, and the side in front of the 90 degree are acts like hypotenuse as we did here, D. So this perpendicular distance which is in front of angle will be hypotenuse d times sine theta here, and here hypotenuse is r, it will be r sine theta, right? So it means if we are applying the force in this direction, the perpendicular distance in position 1 was r, but when we apply the force at some angle to the r, the perpendicular distance now decreases to r sine theta. So now the perpendicular distance will be r sine theta, which will be less than as compared to position one. So we multiply f with r sine theta. So now the formula for movement will be fr sine theta. I'm repeating. If the force is making 90 degree with the distance, it's simply force multiplied by distance, perpendicular distance. But when the force is making some angle with the distance between pivot and force, then the perpendicular distance will be fr sine theta. Then formula will be fr sine theta. If force is perpendicular, then formula of movement is f times r. If the force makes angle theta with the distance r, then the formula of movement will be fr sine theta. Will you remember? It is the
Yes, sir.
derivation number one. There is another derivation. Let's say we apply the force like this. We apply the force like that, as we were doing here. Let's say we divide it into two components. What is this component? F cos theta, as it makes angle theta with the horizon. And this component is F sine theta, right? Ji Hassan, let's say this was the force, and here it was making angle theta here with the horizontal, and this component will be F cos theta, the other component will be F sine theta. Is it clear, Hassan?
Yes, sir.
Okay. Now, do you think that this F cos theta will produce any movement or turning?
No.
No. Why? Because it's passing through, its direction is passing through the
Pivot.
pivot. So it will not create any turning effect. But F sine theta and its perpendicular distance from the pivot is R. This whole distance is R. Right, beta ji? So F sine theta will produce a turning and its distance is R. And when you multiply F sine theta by R, in multiplication we can rearrange these values. The F, the sine theta and R as FR sine theta. So it means here as here only F sine theta was active or was effective, F cos theta was cancelled, was not producing any turning effect. So F sine theta will be multiplied by R and it is also making 90-degree with the distance. So the formula again is FR sine theta as we did here, right? So these were two derivations, and what is the effect of derivation and what is the result? If the force is making 90-degree with the distance, it is simply force multiplied by distance. But if the force is making theta angle, some angle with the distance, then the formula will be FR sine theta in each case, right? क्लियर हसान समझ आया दो डेरिवेशन थी बेटा यहाँ
जी सर.
दोनों तरीके से both give you answer FR sine theta, right, Surosh? Is it clear?
Yes.
Okay. Now we are going to discuss the last point for today. We are not having a longer class. But a couple. Couple means two. I want you to write. Usually when we have to open a cap or close a cap, we apply with force with two fingers. Yes, one finger can also work, but it is properly or easily, conveniently rotated with two sides, fingers on two sides. Like the steering we rotate, it is rotated usually with two hands. Yes, but one hand can also operate, or steering can be operated with single hand as well, but we can rotate by using two hands. Similarly, here, when the spanner was making it rotate, you would have, can notice actual the spanner touches the nut here and here at two sides. And if it rotates like that, now this side goes there and this side goes there. Opposite forces. Right, beta ji? This tells when two opposite forces act on the same object, they form a couple. Hold on. Couple means two. So what is the couple here? It is the couple of forces, the two equal and opposite forces. But have a look at this example. Don't you think when two forces are acting and equal and opposite forces acting at same point, they cancel out each other, isn't it?
Yes.
So it means nothing will happen. But if one, if the both the forces are acting at two different points, one is acting at this point, other end, this rotates the object like that, the other rotates the object like that. In which direction does it rotate? Anti-clockwise. What
Anti-clockwise.
is this direction?
Anti-clockwise as well.
That is anti-clockwise both. It means actually both are rotating the object in same direction. They help out each other. They add into each other. So beta, what happens if equal and opposite forces act at two different points, not the same points? Then they make the object same type of produce same type of rotation in the object and make the object rotate. So that is a couple. So can you write? What do you mean by couple? To equal and opposite forces, are you writing?
Yes.
To equal and opposite forces acting at to equal and opposite forces acting at two different points of the same object form a couple of forces. Two equal and opposite forces acting at two different points of the same object form a couple of forces. We can also say having different line of actions rather than saying different points means here they were having same line of action, but here the line of action of force is this one and they have different line of action. So it could be the same. If we say the forces are acting at two different points or their line of action is different, both mean the same, right? And what is the effect? You have to write the couple makes the object rotate. The couple can or may make an object rotate. Sometimes the couple or turning effect is not sufficient enough to make the object rotate. So we should say right, can or may, right?
Yes,
Okay.
sir.
Now, if we want to find the moment or torque of a couple, moment and torque both mean the same. Sometimes teacher relate torque only with couple, but it's same. If we want to find, let's say, this is a rod or any object, it could be a steering like we have, or a lid or nut. So let's say you can take an example. Here is a rod and two forces F or equal and opposite forces acting and two different points A and B. When it rotates, there will be a central rotation that will be the central rod, that is C. So central rotation is called as pivot. So if we want to find the moment of the couple, we will add both of their moments. So the moment of this force acting at point A will be force multiplied by perpendicular distance between pivot and force, that will be AC. Here for this force, the distance is AC, right? So the moment of this force is F times AC. And for this force F, its perpendicular distance from the pivot is BC. So its moment is written here. And the total moment, as both are in the same direction, so they will add up into each other. We can take F common. It will be, if we take F common from these both of these brackets, so inside the bracket we will be left with AC plus BC. Is it fine? Hassan, do you understand?
Yes, sir.
Because if you see AC is this much and BC is this much, and when you add, isn't it the whole length of the road? Let's see, the whole length of the road is R, so it will be R. So moment or torque of a couple is F into R. But you would say the initial formula of moment was also F into R. No, there is some difference. When we are taking the moment of a couple, the F for finding couple, we need any one of the four. And here R is the perpendicular distance between the forces. It's not perpendicular distance from the pivot. Here, if you consider R makes 90-degree with both the forces. Here, R is not perpendicular distance from the pivot. It's the perpendicular distance between the forces. This is the most important. When we are finding the torque or moment of couple, the perpendicular, we multiply any one of the force with perpendicular distance between the forces. Yes, beta, what do you want to say?
And we're saying is the distance between the forces in the event that one force is applied nearer to the pivot and the
Yes,
other
yes, yes,
further.
yes. Let's say we one force is there, the other force is there. Again, you will take this distance, which makes 90-degree with both, right?
Yes.
We are doing example for that. Can you? Let's do that straight away. So Think there is a road. Can you see? And when we were applying a force F here, upward and downward, and we will never change the direction of force in these three positions. Clear? Okay, let's have a look at this. So here we apply a force F, and what will be the perpendicular distance? This will be the perpendicular distance between the, let's say this is D1. So here the moment will be force multiplied by this perpendicular distance between the forces is D1, right? So here the moment will be forces multiplied by distance, perpendicular distance between the forces, that is D1. Right, Vetaji?
Yes.
But when the what happens as a result of these two forces, the rod will rotate. The rod will rotate like that, and now will come in this position. Now we are in this position, and again here we are applying the same forces, upward and downward, same amount of forces in same direction. But here, now the perpendicular distance between pivot will be this. Now the direction of force, the pivot perpendicular distance will be this. Isn't it less than this d1? है ना? Now the perpendicular distance between the forces is lesser, and we call that distance to be d2 for this position number 2. When the rod reaches this position number 2, we keep the forces same direction, but here the perpendicular distance is reduced. So there will be, you can say, here will be maximum movement or torque, and here it will be a lesser torque or movement. But what if it keeps rotating and it reaches the position 3, and we keep the forcing as it is, the upward and downward? What will be the perpendicular distance between now these forces? They are in the same line. So the perpendicular distance here will be 0, right? There is no perpendicular distance between the forces because they are in the same line, right? So the perpendicular distance 0 and multiplying 0 with some result is 0 means there will be no rotation. Now, stop being scientific. Just tell me, if we apply the on force on a vertical road like this, will there be any rotation?
No.
So
No, sir.
the formula is saying the same. It means the logic and formula both agree. And when it happens, the logic and the formula both give the same result. It means the formula is perfect, right? So here, in the same road, the same forces, when it keeps rotation, during the rotation, the perpendicular distance between the forces keeps changing. Right, Beta ji? Clear?
Yes, sir.
So
Yeah.
that is all what I wanted to have for you today. If you have any question, you can please